Okay, we got two more parameters to talk about, and we're going to try to cover it all in one page, or 2 pages in one video. And we'll move a little bit quicker. So now we're going to use our graphing calculator to determine the effect of a, which is in front of, multiplied by the function. Alright, so if a is 2, that is 2 times f of x, or in this case, since f of x is a parabola, it's 2 times x squared. We're also going to cover 1/2. It's 1/2 f of x, or 1/2 x squared. And let's just talk about what we see. So I'm going to go to my graphing calculator. I'm going to go to y equals, and we're going to make this guy down here 2, let's clear that whole thing out, 2x squared. We're going to make this whole thing here 1/2 x squared. And we'll just graph them in order. So there's the parent function. Here comes 2 times x squared. Oh, look, it's skinnier. It's been pulled up and stretched. And there's the 1/2 x squared, right, which has been flattened out. And I'm going to show you a lot more when we get to class, but we know this. So if I had the parent function, I'm just going to draw them all here. All right, I'm going to draw a big one right here. If this one right here was x squared, this one here would be 2x squared, and this one out here would be 1/2 x squared. What's really happening is this. Everything when you do 2x squared is being pulled twice as far away from the x-axis, which I probably should have graphed this a little different, but if I go this far with x squared, I go twice as far, and I realize that's a little bit more than twice as far with 2x squared. When you do 1/2 x squared, it's a vertical stretch to be pulled up, or a vertical shrink, right? Everything that is pulled up here is only pulled half as weight. And I'm going to go ahead and I'm going to create a little table for you just to show you on this. So if this was f of x, right, and I plugged in a 2, then the parent function would give me a 4, right? And the well, if this was x, excuse me, I plugged in a 2. And then if I said 2x squared, which would be this function right here, right? 2 squared is 4 times 2 is 8. Twice as far as an output value. So my y's have pulled twice as far up. If I had a 1/2, right, x squared, that would give me 2 again. So what it's doing is it's pulling me away from the x-axis if it's x squared, 2x squared with an a value of 2. And it's shrinking me towards the x-axis when the a value is 1/2. Alright? So what it really has to do is whether the a value is greater or smaller than 1. So let's come down here. Right? Now we're going to talk about the b parabola. Notice b parameter. Notice that the b parameter is also being multiplied by x. So we're going to do both of these again. We're going to say, hey, if b, notice b is on the bottom. If b is on the bottom, right, we got 1/2 x. 1/2 x squared is a function. It's 1/2 x, and as the parabola, the actual function we're using is 1/2 x squared. So if I plug that in, let's go ahead and do it. When b is 2, I get something that looks like this. Right, I'm going to go down in there, and I'm going to put in parentheses, because it's a quantity being squared. All right, we've got 1/2. And I'm going to separate it from the x. I'm going to put my x there, end parenthesis twice, and I'm going to square that quantity, and we're going to see what happens. So when I do that, look what happens. Alright. So this is a horizontal stretch. Horizontal means I'm taking this and I'm pulling it out here. So when b is bigger than 1, which is again a little bit counterintuitive because when b is larger than 1, it comes out as a fraction. If I plug in 1/2, let's think about this. If I plug in 1 over 1/2, because b is on the bottom, it actually turns into a 2x squared, right? So if I do that, if I plug in 1/2, it turns into, in parentheses, the quantity 2x squared. Alright, when I graph that, you're going to see that that is a horizontal shrink. So what we're talking about when we do B is either a horizontal stretch, which means I get longer or I get stretched out horizontally, or a horizontal shrink. Alright, so this one right here, if this was my parent function, right, the B is 2, it gets stretched out horizontally. Right. This one right here, if that was my parent function, it gets compressed, or it's a horizontal shrink. Right? So we are going to have to talk about this, and I'll explain it in class. But a vertical stretch, which is this guy right here, is not always the same as a horizontal shrink. In fact, if we graphed these two, they would not graph the same. If I graphed 2x squared with the quantity 2x squared, they would graph differently. And we'll talk about why when you guys come in on Monday, or if this is a different year, whatever day we're covering this on. All right. So we can represent stretches and compressions in the function, right, by changing the parameters a and b. In general, where the equation g of x is a transformation of the graph of f of x. All right, a happens outside the function, and b happens inside. And when it's outside the function, it changes the y. When it's inside the function, it changes the x. Alright, it's a stretch when a is greater. We'll say the absolute value of a, because that'll come into play later, is greater than 1. It's a compression when the absolute value of a is less than 1 but greater than 0, which absolute value would imply that. Alright, the b, it's a stretch when b, right? It's a stretch when b is greater than 1. And remember, that looks like a fraction though. Right? That's going to look like a fraction. And it's a compression when b is less than 1. Okay? So let's go ahead and down here. This right here is an a of 3, which is a vertical stretch. Right here. This one's tricky, right? This is a b of, it's counterintuitive just like the h was, 1/3, because I had to plug it in like this. I had to plug in f of 1 over 1/3, right? And that's what gives me my 3, right? Because the b goes on the bottom when you plug it in. All right? So when I plug in 1/3, all right, it is going to give me a horizontal shrink. Alright. Or compression would be a good way to write that. This one right here, a equals 1/3, which is a vertical stretch. This one right here, this is b equals 3, not 1/3, remember, because the b is always on the bottom, which is a horizontal stretch. And I messed this one up. We're going to go back here. A being a 1/3 is a horizontal shrink. I think looking up here made me think the opposite. But so the rules are, when a is bigger than 1, stretch. A is less than 1, shrink. Alright. B is smaller than 1, but it looks a little counterintuitive, horizontal shrink. B is greater than 1, horizontal stretch. There's one other thing that happens, and I think I'll cover it in the next video, and I'll talk to you guys soon, and that'll be good for this weekend.